Next, we're going to learn the quotient rule. So quotient rule is, of course, for taking derivatives of quotients. So I'm just going to write up here the derivative of f of x over g of x. So it's a little bit of a pain. You've got g squared in the bottom, and then you have g times the derivative of f minus f times the derivative of g. So unlike the product rule, you have to be a little bit careful, like which one's first, right? So you don't get the wrong sign. So people have different mnemonics for remembering it, like bottom d top minus top d bottom or whatever. Whatever works for you, it's fine. Whatever works. But this is the formula. You're going to have to remember the formula. Okay? So let me do a couple of examples with it. First, here's one. Right, so similarly to with the product rule, what I usually do is write it down. I'm going to start over here. So I take the bottom and square it. And then I've got the bottom times the derivative of the top minus whoop, the top. I didn't leave enough space. I'm going to scrunch it in here. 2x minus 1. Okay. So then taking it down to here. So I have space. I'm going to do 2x minus 1 times 24, then x cubed minus 14x minus 6x to the 4 minus 7x squared times 2. And the bottom is 2x minus 1 squared. And of course, here's the question always, okay, can I just leave it like that? How much do I have to simplify? It's nice to simplify at least a little bit. So do a little bit of, you should kind of work it out, make it a little bit nicer. But on the other hand, it is also kind of a pain. So I don't really know. On an exam, like I guess I would say on an exam, I wouldn't necessarily require that you simplify this because basically you're wasting your exam time with a lot of algebra. But on a homework or something, you know, working it out is kind of nicer, right? So I can get a little bit of a nicer looking result to look at as my final answer. So 48 minus 12, so it's going to be 36, right? 36x to the 4. And sometimes you might actually have to simplify. And this, of course, holds for these as well as next week's when we have the chain rule. Those can get really long and ugly. Plus 14x squared minus 14x. There we go. Yep. So, but sometimes you might have to simplify. For example, if we were asked to solve for where this function had tangent lines that were, you know, horizontal, and then we'd have to set this equal to 0 and solve it. Thank God we don't have to do that, right? Yeah. We then have to factor this cubic, which doesn't look very pleasant at all. Anyhow, but this is good enough, right, for this. And so I'll do one more, but pretty much these and the other ones, the product rule, the quotient rule, are pretty straightforward. It's just a question of remembering the formula, and what's going to happen is after doing a bunch of practice with all those formulas, you will remember them just because you use them all the time. They just kind of they will move into your brain. Yeah. So my second one is find an equation of a tangent line. So let's see what we have here. Equation, I'll write it up here. Equation of the tangent line to, what do we have here? 1 plus x. So these aren't terrible. 1 plus e to the x at point 0, 1/2. Right? So now we just use this to take the derivative. Bottom is going to be 1 plus e to the x squared, and then I've got 1 plus e to the x times the derivative of 1 plus x minus 1 plus x times the derivative of 1 plus e to the x. Right? So then, cleaning this up a little, the derivative here is just 1. And then the derivative here is just e to the x. So I eventually, I'll put it here, right? The e to the x's cancel out, right? 1 plus e to the x minus e to the x plus x e to the x over 1 plus e to the x quantity squared. So my derivative is this guy. Okay? So what I want to do then is find out what it is at the point 0, right? So y prime of 0, I just put in 0. I have 1 over 1 plus 1 squared, right? So I end up with 1/4. And then I'm going to then make a tangent line, the equation of the tangent line. So here I've got, I'll put it up here so we can see better. Y minus 1/2 is 1/4 times x minus 0, or my final answer, 1/4 x plus 1/2. There. Okay, so fairly straightforward. And I'm going to say there is sort of like a mini proof of this in your book. The proof of the product rule is bad enough. So in terms of, do you really need to look at the proof from this? I don't know. In fact, typically I use the chain rule to prove this, and that's for next week.